All right, today we are going to tackle a question that, believe me, trips up almost everyone when they're starting out in machine learning. This is the single biggest leap you can make from just, copying and pasting code to actually understanding what you're doing.
So let's just kick things off with this question. Imagine you've built a model, you run a test on it, and it comes back with 100% accuracy. A perfect score. So is that a good thing? Just take a second. What's your gut reaction?
The answer? It's probably cheating. Yeah, I know, that sounds totally backwards, right? A perfect score feels like you've hit the jackpot. But in machine learning, if something looks way too good to be true, it almost always is. Think of it like this. Let's say you're studying for a huge test, and when you walk into the exam, the teacher hands you the exact same questions that were on the study guide. Of course, you're going to get a perfect score. But did you actually learn the material? Nope, you just memorized the answers. It's fake intelligence. And that is exactly what a model is doing when you test it on the same data it already trained on.
So how do we give our model an honest-to-goodness test? A real final exam it can't cheat on? Well, that brings us to probably the single most important idea in model evaluation, the train-test split. The whole idea is actually pretty simple. We take our entire data set and we just slice it up. A really common way to do this is an 80-20 split. We take that big 80% chunk and use it for training, to teach the model. And that smaller 20% piece, we lock it away in a vault. The model never, ever gets to see it while it's studying.
You see, these two sets of data have totally different jobs. The training data, that's the textbook, the practice problems, all the study material. But the test data, that's the surprise final exam. It's the only way we can really know if our model has truly learned the underlying patterns or if it just memorized the answers from the book. And this is so important, this difference between a model that memorizes and one that genuinely learns. This is the #1 pitfall we're trying to avoid, and it has a very specific name.
Overfitting. This is what happens when a model gets so obsessed with the training data that it learns every little detail, every random quirk, every bit of noise. It becomes a perfect mimic of its study material, but the second you show it a new, slightly different problem, it completely falls apart. It just can't generalize.
Okay, here's a really simple way to remember this whole thing. An underfit model is too simple. It's just too dumb to even find the pattern. An overfit model is way too complex. It's too smart because it has literally memorized everything. What we are always aiming for is that sweet spot in the middle, that Goldilocks zone, a good fit that is just right.
All right, that's enough theory. Let's get our hands dirty and actually see all this stuff in action. We are going to build a real classification model, a simple predictor to see if a loan application should be approved.
Now, to do this, we're going to use a technique called classification. This is different from regression, where you're trying to predict a number, like the price of a house. With classification, we're predicting a category. In our case, the question is super simple. Will this loan be approved or will it be rejected? It's a yes or no answer. So here's our game plan. We'll import our tools, whip up some data, and then, and this is the most important part, step 4, we'll split that data. Only after that will we train the model and finally test it to see how well it did. So let's get started with the data.
First things first, we need some data to play with. We're going to create a super simple data set here with just 2 features, a person's income and their credit score. And then we have our target, which is whether their loan was approved or not. We'll use a 1 for approved and a 0 for rejected. Nice and easy.
And look at this. Step 4, our star player, the train test split. We're basically just telling the program, hey, take our features and our labels and split them up. And make sure you hold back 20% of that data for the final exam.
And this is the moment of truth, when we actually train our model. Notice we are only feeding it the training variables. The test data is still locked away, totally hidden from view. This is where the real, honest learning happens.
Okay, so after all that training, we finally unleash our model on the test data it's never seen before, and boom, a perfect accuracy of 1.0. Now, hold on. Because we used the train test split, this isn't cheating. It means our model actually learned the pattern from the training data perfectly. But, and this is a huge but, in the real world, a 100% score is a massive red flag. We're only seeing it here because our data is super small and perfectly clean. What really matters is that we followed the process correctly.
Let's just take a quick breath and recap the seriously powerful new concepts you've just seen in action. I'm not kidding. This is the stuff that separates the people who are just starting out from the people who really know what they're doing. I mean, really think about what you've just mastered.
You now know how to use trains test split to give your model a fair and honest test. You know how to use accuracy to actually judge its performance. You understand the huge danger of overfitting, of a model that just memorizes instead of learns. And on top of all that, you just built your very first classification model. That is a massive, massive step forward.
So, you've successfully built a working model. That's fantastic. Seriously, congratulations. But the real learning, well, that starts right now. The next question you should be asking yourself is, can you break it? How can you push it and challenge it to understand it even better?
So, here's your mission. Try these little challenges. Add some more rows of data. What do you think will happen to the accuracy? Change that test size from 20% to 50%. Does it make a difference? And most important, try to predict a totally new applicant. Go on, experiment with it. Because building a model is one thing, but truly understanding it, that's everything.